We are now going to solve an equation using a method called trial and improvement. This means we are finding the solution value of x, which gives us the target number. In order to do this, we need to draw a trial and improvement table with 4 column headings. The first column heading is the solution value of x. Then we have the chosen x values. The third column across is the left-hand side of the equation, which in this case is x cubed plus 5x. And then finally we have our output column. So to start off, we have to find 2 consecutive whole numbers of x, such that when we sub them into the left-hand side of the equation, one of them will give us an output value which is smaller than the target number, and the other one will give us an output value which is bigger than the target number. Now, they've been very helpful in this question. They've actually told you what x value to choose first. So they've said, look, choose x equals 2. So we go to our chosen x values column, and the first x value we're going to choose is 2. And what we're going to do is we're going to sub this value of x into the left-hand side of the equation to see what our output value is. So replace everywhere you see x with 2. So we're going to get 2 cubed plus 5 times 2. Again, make sure you use brackets when you're subbing a number into a formula that has a power and when you're subbing in a number that has a coefficient. So again, we can use our calculator to evaluate. So open your brackets and then close it, and then hit your little Xbox button there. Then it brings up a little box for your power. Type in 3, then scroll to the right to make sure the flasher is flashing after the 3 but down low, and then add on 5 bracket 2, and then hit equals. And then that's going to give you 18. So our output value is 18. So we've chucked a value of 2 into the left hand side of the equation, and we've got an output value of 2. Now the output value is smaller than the target number, so we put a little s beside it. So we now pick the next whole number value of x, which comes after 2. So we're now going to pick 3. And we're going to do exactly the same. We're going to chuck 3 into the left-hand side of the equation. Again, we can work out the output value by typing it into our calculator. And then hit equals. That's going to give us an output value of 42. So this time the output value is bigger than the target number, so we'll put a wee b immediately after it. So we've now chucked 3 into the left hand side of the equation, and that's given us an output value of 42. It's bigger than the target number. Now, straight away, we've now established the gap that the solution value lies between. The solution value at the minute lies between 2 and 3. So remember, when you chuck 2 into the equation, you got an output value that was smaller than the target number. You then chucked 3 into the equation and you got an output value that was bigger than the target number. So because the target number lies between 18 and 42, that means the solution value of x that gives the target number lies between 2 and 3. So we've now got the gap that the solution value lies in. What our job now is to do is to narrow the gap or shorten the gap. We want to make the gap smaller each time, so eventually the solution value will pop out of it. So the next x value we choose depends on the x values that are at each end of the gap. So at each end of the gap we've got an x value of 2 and 3. They have the same number of digits. They both have 1 digit. They have the same number of digits, and their last digit differs by 1. So the next x value we pick is halfway between them. So we then pick 2.5. And we do exactly the same. We chuck 2.5 into the left hand side of the equation. And again, we go back to our calculator, type it in carefully. And hit equals, hit your SD button to turn it into a decimal, 28.125. So when we chuck 2.5 into the left hand side of the equation, we get an output value of 28.125, which is still smaller than the target number. So every time we work out a brand new x value and we chuck it in to get an output, we need to recalculate or reevaluate the gap. In other words, shorten the gap. So the gap was originally between 2 and 3. When we chucked in 2, the output was smaller, but when we chucked in 3, the output was bigger. Now we've chucked in 2.5 and the output is smaller. So we're now replacing 2 with 2.5 because they both give outputs that are smaller. So the gap has now shrunk. It's no longer between 2 and 3. It's now between 2.5 and 3. So this is our brand new gap. Now, we have to pick another x value. Again, the x value you pick depends on what the x values are at each end of the gap. So at each end of the gap, you'll notice that the x values do not have the same number of digits, so you can't go halfway. This only has 1 digit, this is 2 digits, so we can't go halfway. Instead, we look at the output values for each of those x values. And we look at the output value which is closest to the target number. So clearly 28.125 is closer to 29 than 42 is. So the next x value we pick is between 3 and 2.5, but it has to be closer to 2.5 because 2.5 gives an output value closer to the target number. So next x value we pick has to be between 3 and 2.5, but closer to 2.5. So we're now going to pick 2.6. So again, we take our 2.6 and we chuck it into the left hand side of the equation. And again, type it into your calculator carefully. Hit equals, hit our SD button. That's going to give us 30.576. So when we chuck in 2.6, our output value is 30.576, which is bigger than the target number, so we put a B beside it. And again, we have to recalculate the gap, or reevaluate the gap. So the gap used to be between 3 and 2.5. When we chucked in 3, we were bigger than the target number. When we chucked in 2.5, we were smaller. But now when we chuck in 2.6, we're bigger. So we are now replacing 3 with 2.6. So the gap now lies between 2.5 and 2.6. Now, the next x value we choose depends on what the x values are at each end of the gap. So you'll notice now the x values at each end of the gap have the same number of digits. They both have 2 digits and their last digit differs by 1. So that's when you then go halfway. So the next x value we pick is halfway between 2.5 and 2.6. So we're going to choose 2.55. So again, we chuck 2.55 into the left hand side of the equation. And again, we go to our calculator and evaluate. And that's going to give us 29.331. So when we chuck in 2.55, our output value is just slightly bigger than the target number, so we'll put a B beside it. And again, we have to reevaluate or recalculate the gap. So the gap used to be between 2.5 and 2.6. When we chucked in 2.5, we were smaller than the target number. When we chucked in 2.6, we were bigger. But when we chuck in 2.55, we're bigger. So we're now replacing 2.6 with 2.55. So therefore, the gap is now between 2.5 and 2.55. Now, there's good news. We don't need to choose any more x values because we're now working with an x value to 2 decimal places, so we stop. So we've now found the final gap that the solution value lies between. So the final gap is between 2.5 and 2.55. So we write that gap down underneath our table. So we put 2.5 down, it's higher up, and then we put 2.55 just underneath. So we just illustrate that's our final gap that the solution value lies between. So what we do now, because one of our end values has 2 decimal places, is we write down all the other decimals we can think of to 2 decimal places which lie between 2.55 and 2.5. So go to the smaller end value, which in this case is 2.5, and write down all the decimals you can think of with 2 decimal places that lie between it and 2.55. So we've got 2.51. 2.52, 2.53, 2.54. Now what you'll notice is all of those red decimals, if I were to round them all to 1 decimal place, each and every one of them would round to 2.5 because the digit that comes immediately after is less than 5, so you would keep all of these 1 decimal places the same. So they all round to 2.5 to 1 decimal place. Now, here's the logic. All values between 2.5 and 2.55 round to 2.5 to 1 decimal place. Well, the solution value also lies in here, so it must also round to 2.5 to 1 decimal place. So the final answer is just the solution value of x must equal 2.5, and that is the 1 decimal place. Now, this is what our answer means. We have found the solution value for x to 1 decimal place such that it gives an output closest to the target number. So what we're saying is that if you look at all the x values in your table that are to 1 decimal place, the x value that gives you the output closest to the target number is going to be 2.5, because if you compare 2.5 and 2.6, you're only comparing the decimals in the table to 1 decimal place. 2.5 gives an output of 2.28.125, 2.6 gives an output of 30.576. 28.125 is closer to 29 than 30.576. So that's why the solution value to 1 decimal place has to be 2.5. It's the value of x to 1 decimal place that gives you the output that's closest to the target number.